So this question is about the extension of a wire when a force is exerted, and it requires you to have an understanding of Hooke's law and being able to rearrange ratios to enable you to work out the relationship between two values. So just looking at the data sheet, so you're given, right at the bottom down here in the materials section, you're given that Young's modulus is equal to tensile stress and tensile strain. And you are told that for that these materials are the same. So the Young modulus will be the same for each of them because they're the same material. So stress over strain will give you the Young modulus, and that will be the same for both of them. So stress is F over A, and strain is delta L over L. So if you then were to write that, so Young's modulus, often written as E, is given as stress over strain, which you can write as F over A over delta L over L. And that ends up with the Young's modulus is FL A delta L. Now, the reason why I've done that is so we can see the relationship between these the values. What I would then do is to rearrange for delta L to see what delta L depends on. So delta L is equal to FL over A multiplied by the Young's modulus, which in this question is a constant. So the extension depends on is proportional to the force, is proportional to the length, is inversely proportional to the area, but bear in mind that the area is given as, if it's a cross-sectional area for a circle, which is we've got the case here, and then it's going to be varying with r squared. So this should help us then work out what's going on. So if we look at line A, we've halved the length, so we halve the extension, and then we double the radius. So we double the radius, then that quadruples the cross-sectional area, and that will reduce the extension by a factor of 4. So line A, the first part, we've halved it, and then we've reduced it by a factor of a quarter. So they'll combine to give us an eighth. That's not what we want. Then we've got line B. We've got the same length, and then we've got an increase in the radius of 4, which will increase the area by a factor of 16. So it's a 16th. So that gives us a 16th. That's not right. And then we have C, just moving that down a little bit. And we've got C, where we have doubling the length. So that'll double it. And then we've doubled the radius. That'll quadruple the cross-sectional area. So that gives us an overall halving of it. And then D, the final line, which is hopefully going to be the right one. We've multiplied the length by a factor of 4, so we get 4 times the extension, but then we've increased the radius by a factor of 4, so it's 4 squared. So we've increased that the area by a factor of 16, so we get 1/16 of the extension, and they will give us an overall extension 1/4 of the original value. So that one is the correct one.